Hello everyone, and welcome back to another statistics video. In this video, we're going to look at testing the claim about a mean when we do not know the population standard deviation. And this is going to end up being a t-test. So let's look at some information. So what are the requirements? The sample has to be a simple random sample, I'll correct that in the notes, a randomized experiment. And the sample has to have no outliers, and the population from which the sample is normally distributed, um, or the sample size has to be pretty large. And usually we use n is greater than or equal to 30 for that, and that comes from the central limit theorem. And then the sample values are independent of each other. So our test statistics going to look like this. We're going to use technology to compute this. We could do this by hand if we wanted to. So let's look at a few examples. The good thing about hypothesis testing is that they pretty much all work the same way once you know those basics. So let's look at a few examples using the t-distribution. So when 40 people use the Weight Watchers diet for 1 year, their mean weight loss was 3 pounds and the standard deviation was 4 pounds. So for the 40, their mean was 3 and their standard deviation was 4.9. We're going to use a 0.01 significance level to test the claim that, so here's our claim, the mean weight loss is greater than 0 pounds. So that's giving us our hypotheses. We're looking at testing the claim about the mean. That's how we know we're using a t-distribution. And the mean is greater than 0, which means the null is equal to 0. So if we wanted to do this by hand, just to show you how we would use this information, we would first find our test statistic. So our test statistic is x bar minus the mean divided by s over square root of n. So our x bar is 3. Our mean is 0. Our standard deviation was 4.9. And our n was 40. So if we plug all that in the calculator, make sure you put parentheses around the top and around the bottom. And when I do that, I get 3.872. So now we got to figure out what our p-value is. This is a right-tailed test because it's greater than. So 3.872 is here. And we're going to use salt distribution. And this is a t-distribution. Degrees of freedom would be 39. Remember, it's n minus 1. We want the probability of being larger than 3.872. And that probability is 0.0002. So there's our p-score. P-value. And since p is less than alpha, we would reject. So if we wanted to do it by hand, that's how we would do it by hand, using the p-value method. Let's use salt to do that. Inferential statistics, we are going to choose a one sample t. Our sample variable, let's reset this. So I'm going to go back to data set and I'm going to uncheck that. I think it's trying to read that data set. So one sample t. Our sample mean is 3. Our sample standard deviation is 4.9. And our sample size is 40. We're doing a hypothesis test that the mean is equal to 0 and the alternative is greater than 0. When we do that, you can see your p-value here, 0.0002. There's the test statistic we came up with. So p is less than alpha, then we're going to reject. So we just got to figure out how are we going to phrase that final wording. The original claim does not have an equality and we reject. So there is sufficient evidence to support the claim. So let's look at the next one. And this is where you may want to pause the video, try it, and then come back and check your answer. So looking at this one, researchers collected a simple random sample of times that 81 college students required to earn their bachelor's degrees. So we have 81 as our N. The mean is 4.8. The standard deviation is 2.2. We're going to use a 0.05 significance level to test the claim that the mean time for all college students is greater than 4.5, and that's to earn a bachelor's degree. So let's write down everything we know. N is 81. That sample mean was 4.8. Sample standard deviation is 2.2. Alpha is 0.05. H naught. Mean is equal to 45. H1, the alternative, the mean is greater than 45. This is a right-tailed test. So let's use salt. Let's reset this. Our mean is 4.8. Standard deviation is 2.2. Sample size is 81. Hypothesis test, 4.5 is our hypothesized mean, and we are looking at greater than. So here's our test statistic. Here's our p-value, 0.1117. Notice our p is greater than alpha, so we are going to fail to reject. So we're going to go back to our wording. We do not have an equality, but we fail to reject. There is not sufficient evidence to support the claim. At the meantime, for all college students to earn their bachelor's degree is greater than 4.5 years. And let's look at one more. So with this one, we've got a data set. That means we're going to have to type it into Excel, save it as a CSV file, and then upload it into Salt. So let's pull out the information before we go about doing that. So we're using a 0.01 significance level to test the claim that recent Miss America winners are from the population where the mean BMI is less than 2.6. I mean 20.16. All right, so we're going to go into Excel. We're we're going to type our values in. So we have 19.5, 20.3, 19.6, 20.2, 17.8, 17.9, 19.1, 18.8, 17.6, 16.8. And we're going to save it and then we're going to upload it. Go to salt. Now we're going to go to data set and we're going to import our data set, upload. That's it here. Okay, so we got 9 of my values. I forgot to leave that first one blank. So I'm going to add a row and just type it in, 19.5. So now I've got all 10 of those values. It does not matter if they're in order. And we're going to do, and we've got that selected, so that's variables. So notice it's using that category for us. We could go back in here. Let me go back in. And I could actually insert a row and call this BMI. And then I could resave. Let me get rid of that and import. And then now it will have BMI as the header for that. And then it will have my 10 values. So we could go in and correct it that way also. Either way would be fine. Inferential statistics, we're doing a one sample T using the variable BMI. Our sample mean, they told us was, oh, actually they computed that for us, and the sample standard deviation. Our hypothesized mean is 20.16. Guys, make sure you don't change anything here. If you're uploading a data set, it's going to generate those numbers for you so you don't have to. And we're looking at less than. My p-value is 0.0023. And our p is less than alpha, which means we're going to reject. We were using a 0.01 significance level. That's what we compared it to. And our hypotheses highlighted is what we're testing the claim about, that the mean is less than 20.16. So the null is equal to 20.16. So we know we're going to reject. So we're going to go back to our table. We reject the original claim, and the claim does not have an equality. So we start by saying there is sufficient evidence to support the claim that. All right, so you can see no matter what kind of hypothesis test we do, it all works the same way. It's finding that test statistic, and then the p-value is tied to the test statistic, and we compare p and alpha.